Okay, so we've run this model with the robust standard errors, and we have now two very robustly significant ones, and we got two borderline relationships that we can draw some inferences in, some qualified inferences. Next thing we're going to do is we're going to produce some predicted values. We're going to make a plot of these, and so I'm going to predict. So we'll enter predict and events. And then comma n, and so that's going to go out there and it's going to run out there, and I don't know, okay, yeah, there it is, and so I had just dropped it, and so down here, predicted n events, it ran, and so down here at the bottom of my thing I should have n events predicted number. Okay, so I just created those. We're actually going to re-import this into SPSS and create a plot, because SPSS is better for plots. The other aspect that we need to do is we want to be able to do some marginals. One nice thing about Stata is that it allows us to do some post-estimation commands and allows you to create what the predicted probabilities are. And we can do that with event counts. And actually, Stata's gotten much more sophisticated since when I was using it last. And so they have these new margin commands. And so we're going to do some of these really quickly, and I'm going to show you how to do them. Before we can do these predicted probabilities, we need to do a couple things. We actually have to re-estimate the model with instructions to tell it that we're going to be interested in predicted probabilities. And so I'm in the command window now. I'm going to arrow up until the last thing that I did, which was this ZNB. This is our ZNB with the robust standard errors and everything else. Now here, what I need to do is I need to tell it that I want it to save certain bits of information so that we can create the predicted probabilities. And we do that by specifying the independent variables differently. So what we'll do is before FC, we're going to do an I.FC. We're going to do an I.SNR. We're going to do an I.hazard. And we're going to do an I.FRH. And so these two were insignificant, they don't matter, and we don't need to do one with number respond. We're going to interact with that one, but that's the step that we need to do. So we'll re-estimate our model with ZMB with firefighter injuries, I.FC, I.SNR, I.hazard, and I.FRH, and run it again. And there's my dog. My dog is currently in Gainesville. He is studying at Oklahoma State University, and he's doing quite well. I think he's going to graduate early. All right, so we've got the same model. The last thing that we're going to do is we're going to run these marginals, but the marginals, and this is really important, when you run these predicted probabilities, you have to do them over representative sequence or intervals of variance. And so I always like to do them with kind of the mean plus a standard deviation plus another standard deviation, right? And so we'll do this with, we're going to go calculate a mean plus, one standard deviation plus another standard deviation and another. So mean up to 3 standard deviations, which will give us a good idea of kind of the general variance that we'll see on these independent variables. Okay, so let me show you where this comes in. First thing I'm going to do is I'm going to summarize or get the descriptive statistics for my 4 variables that I did the interactions with. So I'm going to do sum FC, I'm going to do sum SNR, and I'm going to do sum hazard and sum FRH. Now you'll see that here we have mean values and we have, that's the problem. I just did something wrong. What we actually have to do, we don't do the FC values, we're actually going to interact this versus the number of responders. So I don't do the actual FC or SNR, I actually have to summarize the interactive variables that we used back in that logit model. So my mistake. Summarize FCNR, summarize SNR-NR, summarize HAZ-NR, and summarize FRH-NR. And so what this is going to tell, it's going to tell us the observed range on the number of responders and fire control, and observed range on search and rescue and number of responders. And so see how these summary statistics look different, right? So up here, these are just the dichotomous ones. We actually need to have this interaction with number of responders because that's the marginal that I'm going to ask it to create. So here we start with a mean of, we'll round down, and it'll be 2. And so we'll start with the value at 2, and then we're going to add 8 to it. So we're going to add 2 plus 8 to get 10. We're going to add another 8 and another 8, and we'll get up to 26. Okay. For search and rescue, we start with a mean value. It's damn near 0, so we'll just start at 0, right? And then we'll add, this rounds up to 2, and so we'll go from 0 to 2 to 4 to 6. And this one is, again, 0 essentially, and 2, so we'll go 0, 0 for the mean, 2, 4, 6 for 1 standard deviation, 2 standard deviation, 3 standard deviation. This last one for fire rescue hazard is the mean there is about 3, so we'll do, or the mean is about 1. We round that up. That's significant digits, so 8 would get us to, actually that is 0. I thought it would round up to, well, no, we would round it up to 5, and that'll round up to 5. I'll make it 1. Okay, so that'll be 1, and we'll add to that 3, so it'll be 1, 4, 4, 7, and 10. Okay, let me show you how to do the margins really quick. These are going to be margin calculations, and so the first thing I'll do is I'm just going to type in margins. Then I'm going to say for the one that I'm interested in, so I'm going to say margins FC, and I'm going to do comma at n respond, and then you have to do these kind of multiple things. N respond equals, and you're going to do the first value. So the first one we started it at 2. So it's going to be 2. Put in parentheses the interval 8, which was the standard deviation, and then the final value that we're going to do, so 26. So what that's going to do is we're going to calculate the number. We're going to calculate the probability for FC with number of responders starting at 2 at 2 plus 8, which is 10, plus 2 plus 8 plus 8, 16, which is 18, and then with another 8, which is 26. So here we do margins, FC, comma, at left paren, n respond equals left paren 2, parentheses 8, 26, right paren, and another right paren. Make sure you get the other right paren in there. And so we'll hit return, and you'll see how this margin works. That'll give you a table, and so here it tells you the first observation is at 2. The second observation is going to be for 10 number of responders. The third is going to be for 18 responders, and the fourth is going to be for 26 responders. Right? And so this is the mean plus 1 standard deviation, plus 2 standard deviations, and plus 3 standard deviations. And here, down here, the table will tell you twice, or tell you what's going on. So essentially, this is for our null category. This is for fire control. So for the mean level, it's about a number of events predicted would be 0.01, right? For 1 standard deviation is going to be 0.02 events, right? For 3 standard deviation, it'll be 0.04 events, and for 4, it'll be 0.08 events, right? And so that's what we're going to do. We're going to take this information and we're going to put it into a table. Notice that for these zeros, right, they're essentially 0 all the way down, right? So for the null category, the likelihood of event is exceedingly rare. It's less than 0.01. Okay. Let's go back and let's do the margins for the other categories. Here we're going to do not margins for fire control. We're going to be interested in search and rescue. So let's do SNR. We'll keep the n responders, but we're going to use that other pairing. So we're going to do it at 0. We're going to do it with 2, and then we're going to do it with 6. So it's going to be margins, SNR, comma, at number of responders, start with 0. Our interval is going to be 2, and we're going to end at 6. Let's click that and run. So up here, with 3 standard deviations on fire control, we would predict 0.08 events, right? And for 3 standard deviations for search and rescue, we would predict half that, or even more than half, only 0.03 events. So you see here the effect. Fire control is much more risky than search and rescue. Okay. Let's keep going. Let's do the other 2 categories. These were significant at a 0.05 level for one-tailed tests. So let's just do these. We're going to do HAZ. It's actually going to be the exact same specification. It's going to be 0, parentheses 2 for the interval, and 6. So we can click return. Okay. So here it's going to be the mean is going to be round up to 1. For 1 standard deviation, it's again going to be 1. For 3 standard deviations, it's going to be 1. And for 4 standard deviations, we get up to 0.02. So notice this is less risky than search and rescue, and obviously much less risky than fire control. The final one that we're going to do is for fire rescue hazard, which is fire FRH. Here we're going to change the values one more time. We're going to start at 1. We're going to go to 3. And the last term is going to be 10. So it's going to start with a mean value of 1. The interval for the standard deviation is going to be 3. And it's going to end at 10. Let's run that and see what we get. Okay, and so there we are. We are, and this one isn't very risky either. The third, with 3 standard deviations, it's just getting to 0.01. Okay, so we have some marginal effects. We're going to create a table of marginal effects to show the what our parameters tell us about the likelihood or the number of events that we would anticipate from this model. The last thing that we need to do here is we need to save our log file because we need to print this off. Right, so we're going to go down to log. We're going to close, and so it closed it. The final thing that we're going to do is, because we need to print this off, you'll need to print this off. We need to translate this from this SMCL file into a text file. So I'm going to go up here and I'm going to click on the file. I'm going to go to log. I'm going to do translate, and I'm going to browse. I'm going to go to it should pull up, but if it doesn't, it should be in your, I think if you go to your desktop, let's just click on desktop, you'll click on your H drive, and if you go to project 3 where I had this one, I've got project 3 SMCL, I'm going to then browse again. It should put me right back in the same folder, but let's just do the steps again. H, project 3, and I'm going to say the same thing that I did. I'm going to say project 3 log.txt. Important thing is we label that .txt because that will save it as a text file that we can import into Word and print off easily. Okay, good. Let's translate that, and we should be good. Let me minimize this. Yes, it ran. I'm going to go to my H drive. I'm going to pull up project 3, and right now I've got out there NFIRS, project 2 log, project 3 log, SMCL, and project 3 log text file. Okay, we're good. I'm going to close that, I'm going to close that, and I'm going to do one final thing. I am going to go back and open my stata file, and you should do this too. We need to file, save as. I'm going to save this as, I'm going to click that and save it as 302.dta. Okay. Make sure you save that because we're going to use this values. All right, so let's go back up and look at as far as our variables. When we get down to the end of the variables, we'll have this action code. The last thing that we added was this n events, which is the predicted number of events, and we're going to use that in SPSS in a little bit. Okay, good.